Again, statistics, particularly for sections 12.1 through 12.4, is very much a plug-and-play sort of situation. So it's going to be working through the examples that provide you with your real understanding of what's going on. But still, I wanted to give some insight. I somehow imagine that statistics is actually incredibly interesting. Some people call it statistics, and plenty of people are afraid of it lying to them, but statistics is actually impressively useful. It's one of the more applied areas of math. Can't speak. So maybe you remember that a little while ago we talked about 5 factorial being 5 times 4 times 3 times 2 times 1. With this special factorial symbol, I was able to encode this idea that I was going to have a whole bunch of multiplication going on. So the first thing to understanding statistics is to understand this symbol right here. This is the Greek letter, it's Greek, and it's sigma. It's the Greek letter sigma. It's the Greek S. It's just capital S in Greek. That's all it is. And S stands for sum, which means add it all together. So if I have right here the sum of this x stuff, and I have x is standing in, again it's a variable, it's standing in for something. I have the idea that I'm going to take the first x, and I'm going to add the second x to it, and the third x, and the fourth x, and I'll just keep on adding things up. That's what we're talking about here. So we have the idea of mean. This is a definition. Mean is our usual idea of average. If I told you your average grade in the class, you would probably think that you take your test scores, your final score, and your homework score, add them all together, and divide by 4 or something. That's not quite true in this class, because in this class I use what's called a weighted average. And I'm going to have a video posted closer towards final time that runs through how you calculate a weighted average. But the deal is, you know that your exams aren't worth quite as much as the final exam, and the homework's worth different amounts as well. So you have this idea that some parts are more important than the other. The weighted stuff is going to be a lot like the second part of things we do. But when you're talking about mean, the idea is this. You have one thing, another thing, you add up, maybe if you had 3 things that you were averaging, you'd add them all up and you'd divide by 3. So the formula for this is I have this sigma x, which tells me I add all the x's up, and I divide by n, where n is the number of things I'm dealing with. So that's mean. Mean, and this is the arithmetic mean, it just means average. The problem is when I say average, technically I could be indicating one of about 4 or 5 different things. I think in this book we talk about 3 of them. So average is a very scary sort of word. And you'll find in advertising they say average all the time, and they pick whichever one of those different definitions of average makes their product look the best. So mean tells you right away that what I'm saying is I'm adding up all the values and dividing by the total number of things. So I'm adding up all the values and dividing by the total number of things. Then the next sort of thing that could mean average is the word median. Median means the middle. Think of the median of the road being that cement strip in the middle of the road. Well, that's what this means. And so median is the middle number. It's the middle number in a long list of numbers. The median, if you have an odd set of numbers, well, then it's going to be the one exactly smack in the middle. If you have an even set of numbers, there's going to be 2 numbers in the middle. So you're going to add those 2 numbers up and divide by 2. So if there's an even number of numbers in the list, you're going to add up the middle 2, add the 2 in the middle, and find the mean by dividing by 2. So that's median. And then lastly, we have this idea of mode. So these are the 3 things that we could be talking about in average. Mode is the one number, well, not really one. Mode is the number that appears the most after just showing up one time. So if I just have 3 numbers and all 3 of the numbers are different, then I'd say I don't have a mode. But if I have this list of numbers, this is called bimodal, That means 2 modes, because I've got 2's show up double and 6's show up double. So you don't have to have just one set of modes. And again, mode is sometimes useful, because let's look at this list of numbers. 7, 7, 7, 10. If I looked at this and averaged them all up, using maybe mean, I would get one answer. But really, it would be pretty honest to say that 3 times out of 5 people will get a 7 on this quiz. You know, and I could even say the average. I'll put I won't even write average, because again, you maybe think that more is mean, but I could theoretically tell you the average score on the quiz was 7, because let's face it, this one was kind of weird, and then, you know, we all know that person in the class that nobody likes to talk to. They're the kind of show-off. So, you know, the normal people were getting this, and, you know, this person had a bad day. They just turned 21. So we've got that. Let's talk about a little bit more. This is almost like that weighted average I was talking about. This is what happens if I've got an average where I've got a number of frequencies. So let's look at this example. I've got a grade that a student might get, and I might have a number of students. So the different grades are A, which is a 4.0, a B, which is a 3.0, a C, which is a 2.0, a D, which is a 1, and of course an F. And maybe in a particular class, and this is actually pretty reasonable for a class here at VC, I'm going to have 10 people get Fs. And that doesn't mean that 10 people in the class really fail. I feel like about 8 of these 10 people will have somehow disappeared. I won't have their emails. In this class right now, there's like 8 people whose email addresses just don't work. And they'll just somehow disappear, and I can't reach them. I'll call them, then they don't have phone numbers, and they don't have emails, and I have no idea how they managed to register for an online class without any of these things. But they did, and I can't find them, and they don't find me, and so it's sad and horrible, but there it is. Then maybe 3 Ds. 12 people will get C's, 6 B's, and then 3 A's. So if I'm trying to find the average grade in the course, I can't just do 4 plus 3 plus 2 plus 1 plus 0 and divide it by 1, 2, 3, 4, 5. That's not right. We know it's not right because look, a lot of people were getting 2s. And several people got 3s. So the 3 should count way more than the 1 or the 4. It should count double. And so we have this idea of frequency. And so I still have my sum of all my x's, and I'm still going to divide by the total number of things, but each x I multiply it by f. Not to be confused with f of x, which is a function. Every x value, which is my data value, and then I multiply it by f, which is my frequency. So when I'm setting up this problem here, 4 is my data value, but this happened 3 times. 3 is my number of my B's, but I had 6 B's. 2 is my value for C, but I multiply it by 12 because I had 12 of them. 1 is my value for D, but there were 3 of those. And then, of course, at the very end, I'm going to have 0 times 10, not that it matters. And then I would divide this not by 4, but I'm going to divide this by the total number of people. 3 plus 3 is 6, 6 plus 6 is 12. I'm dividing this by 34 because that's my total number of students that I've got. Just add up this row right here, this column. 3 and 3 gives me 6, 6 and 6 gives me 12, 12 is 24, plus 10 more. That gets me that 34 down there. So I would add up this, and this would tell me my frequency average. If I was looking for a mode in this list of numbers, it would so much be C's because there's 12 of them. Other words we use, mid-range. I take the lowest number plus the highest number and divide by 2. This is another way of kind of finding that median. It gives me the thing that's right smack in the middle. You think of mid-range more if I think of things that are getting measured where maybe median is the middle number in terms of actual scores achieved in a class. So maybe the middle score was a 72. The mid-range, because scores can range from 0 to 100, If I added those together and divided it, mid-range would tell me 50. So median and mid-range can be different, but they have sort of a similarity. You're finding something in the middle. And then it's kind of weird because right in the next chapter, this section rather, they start off and say range is just high minus low. And that just tells me how far it goes. This tells me what my ruler is for this measurement. Again, in a class, 100 minus 0 is going to give me 100, and that tells me, well, I've got a distance of 100 that I could travel in terms of maybe some sort of like one of those cool little thermometer bubble things that show how well are you doing in the class so far. Or maybe when United Way is raising money, I could use the range and say, okay, up here's $1 million and down here's $0. And that would tell me there's this range of 1 million that's going on. All of these things that I've taught so far above range are what we call central tendency. This is all about central tendency. The idea of how do things, tendency tells me like what's the usual behavior for this sort of thing, and it's talking about what the average behavior is. If I group all these things together, how's that working? Once I get into this range area, this starts talking to me about measurements. How long is this distance? Well, it's $1 million long in this thermometer case. How long is the class? Well, there's 100% that I have to achieve in the class, that I could achieve, and I see how far towards that finish line I get. And one of the big measurements in this area is something called standard deviation. Again, I'm imagining that you'll sort of see me use some of these words, and I'll talk you through it, then you'll work some of the examples, then you'll get to an example, and you're like, and then you'll start this video up again. So standard deviation. There's a really, really awesome chart in your book. I'm going to put the page reference in Blackboard, but there's an awesome chart that talks you through standard deviation, but here's the basic formula for standard deviation. It's all inside a big square root symbol, and I've got a fraction bar, and I'm dividing by the total number of things I'm counting minus 1. Then I have a summation, so I'm going to add up a whole bunch of things, and here's what I add. I have a data item, I have a piece of information. From that piece of information, I subtract the mean. So I've got a score, and then I subtract the mean score. What this gives me is the difference between the particular piece of information and what was average for that group of information. And then I square these. The squaring and the square root, all those are dealing with is that by squaring it, I get rid of negatives up here because I don't want to be subtracting. I'm trying to add all positives, and squaring, of course, makes it bigger, but it also gets rid of the negatives. And then taking the square root is going to kind of cancel that out at the end of the day. So this is what standard deviation is. Here's what standard deviation gets me. Standard deviation, because you're subtracting the average off of it, means that when you have the biggest group of people, it's going to be right here in the center. So when you calculate standard deviation, it gives you this center. And then on either side of the center, it starts giving you distances. Each one of these distances, we say, is one standard deviation. Here's another standard deviation. If the range gives me the sort of total distance that I can travel, standard deviation tells me what's the usual length of measurement. So for example, if I'm talking about how far I run in a particular day, I run a couple miles, my usual distance of measurement is going to be a mile. I'm not going to measure out how far I ran in inches. Inches are sort of too small. So standard deviation tells me what's the usual amount that I should be measuring this out with. In particular, for things that we call normal, for groups of informations that we call normal, we get this thing here called a normal curve. Let me erase this blue standard deviation stuff. This normal curve, which I've drawn kind of funky, but there it is. So I'd say this is one standard deviation away from average. Remember, this is my average here, and an X with a little bar over it is what we use to indicate mean. Remember, we take our data item and we're subtracting the mean from it. This allows me to center this at 0. So this is 1 standard deviation away, so it's one of the usual measurement jumps. This is 2 standard deviations, 3. This is -1, -2, -3. When I have this idea of normal, normal means that most people, and so this curve that I have above here, this little black line that's curving around here, that's telling me how many people are inside this area. And in this middle area, between the -1 and the 1 standard deviation, if things are normal, that will be 68% of all the people. If I think about a class of people and I say this class behaved normally, well, I would be saying that 68% of the class earned a C. That would be, and the range of scores that were, so I'd take up all the possible scores in the class and I would calculate the standard deviation. And that would tell me how far off. I'd know the average, I'd know the mean, so I know, the mean score in this class is a 72, and the standard deviation was about 4%. So 4, 5, 6 tells me that a 76% should be the top of the C's, and a 72 minus 4 would tell me that a 68% would be the bottom of the C's. If I was going to curve a class, that's what I would be doing. I don't curve my classes because I think that if I curve a class and everyone earns something like a 90%, well, since 68% has to be in this middle place, suddenly I'd take all those 90s and I'd have to break them down to C's. So that's why I do the normal 90, 80, 70 scale, because I think that if you get an 80% on the tests, that means you deserve a B. And if somebody, if you have a professor who does what they call a strict bell curve, that means that they're going to make most of the people, 68% of the class, is going to get a C, no matter how high they scored. Then next, you have this next highest range here, this 2%. This is standard deviation of 2. If you go 2 standard deviations in either direction, that's going to give you 95% of the whole class. So if I add in the B's and the D's, that should be 95% of the class. What's that tell you? Well, that tells you that on this upper end here, all the people who might earn A's, versus over here, all the people who might earn F's, that's going to be the smallest part of everything. Only 2.5%, because there's only 5% left to give on this outside part. Remember, all this shaded in area in here is 95%. Only 2.5% can get an A. And again, that's why I prefer a 90, 80, 70 scale. I want more people, everyone can get an A. You just have to practice and ask questions and understand and solve things and get that 90%. And then you're good. You don't even have to do 90%, an 89.5. And if you go 3 standard deviations in either direction, that should give you 99.7. That's because you could keep on going more. There is technically 4 standard deviations. All of these things in a class would be called an A. And standard deviations keep on going in any direction. Anything outside of 3, though, in any altogether in any direction, because 3 gets me 99.7% of everybody, is very, very weird. So how do you find out what you are? How do you measure up on this score? Well, in this class, here's what you would do. First of all, you would calculate the mean. You would know all the scores of every student. You'd add those all up together, and you divide by the total number of students in the class. Then you would take all those scores again, plug them in, subtract the mean, square it, add that all up, divide by n minus 1, and take the square root, and that would tell you standard deviation. And then, if I'd done all that, I would have this normal curve for the class. And then how would I say, okay, student, let's say I have a student named Michael. How would I know what Mike gets? How do I know what grade to give Mike? Well, if Mike's falling in here, he should get a C. How do I calculate that? I calculate that with a Z-score. Z-score tells me how you compare a particular person to what's going on. So here's the Z-score process. You take the data item. That would be Mike's score. You subtract the mean. So I've gotten rid of the mean again, just like I did here to take standard deviation in the first place. And then I divide by the standard deviation. And that tells me a z-score, and z-scores are going to give me numbers. Usually those numbers are in between -4 and 4. They're telling me where Mike lives on this particular scale. If you have a 1.3, well, Mike's broken out of the 1 section. Let's start to erase some of this stuff here so I can start to see some things again. If Mike had a 1.3, that would tell me he's outside this 1 section and he's in the B territory. Again, that would be if I was doing a normal curve. Other things that are done with standard deviations. IQ scores. I think the usual IQ test is a Stanford-Binet. What they did is they created this test, and then you make sure that hundreds, not just hundreds, thousands of people take this test. And we average out all the scores once we've added up all the points. And then you find out and you center it. And you could center things at 0. For IQ scores, we centered things at 100. And IQ is based on how many questions, the number of questions answered on the tests, as well as your age. Because as you get older, you should know more and you should be able to answer more things. So it's this joint thing. Is IQ. And we center it at 100. And then you start talking about standard deviations. For most IQ tests, or at least for the Stanford-Binet, I think the standard deviation is 15 points. So what this means is that if this is 100, then over here I have 115, and down here I've got 100 minus 15, which I think gives me an 85. That tells me that 68% of the world should expect an IQ between 85 and 115. This is what we call normal. If you score somewhere in there, you are just like a normal person. And so the difference between 102 and 100 on an IQ score, you don't get to go around and brag to your friends like, oh, I've got 102. I'm way smarter than you. No, you're in this middle usual area of people. And that's what standard deviation gives you. The standard deviation of 15 tells me the usual way you measure stuff here is not by 100 versus 101. It's by 15 points. That's the usual break between understanding. Then next I have this group of 130. Then 145. And then this will give me 160. So this is in the 1 standard deviation, 2, 3, 4. So let's calculate a z-score out for this. Let's say that Mike goes along. So let's say Mike has an IQ of 123. Yeah, I could look and see that he's living in here, but I would like to really calculate out his z-score. So here's what I do. That z-score will tell me exactly what Mike's IQ is in terms of standard deviations. I take the 123 and I subtract 100 and I divide it by 15. 100 because this is the average, and 15 because that's the standard deviation. So this gives me 23 over 15. I call it my calculator. I'm going to get 23 divided by 15. And that's going to give me 1.53. So he's about perfectly halfway in between a standard, normal IQ person and a higher level of thinking person. There's a club called Mensa, and somewhere in here, Mensa, they like to grab high IQ people, and so it's all these people up here. And then there's even other clubs. There's, I think, Ultra Mensa, and then there's other people. One of them is called the Prometheus Society. Prometheus was a Greek character who brought fire from the gods to mankind. And so way up here, I think these are part of what some people call the 999 Society. They are in the top 99%, 99.9% of the world's below them. So they let all those other people live there. And so you've got all these elite groups, and IQ is a very much of a dicey thing. Plenty of people who have very low IQs have done very incredible things, lots of people with high IQs have performed some impressively stupid maneuvers. And IQ, it just measures some spatial reasoning. There's lots of other ways that we interact successfully with the world, besides our ability to manipulate patterns in our head. But that's just an example of one thing. The last thing I wanted to point out in this statistics section was margin of error. And margin of error has a formula, 1 divided by the square root of n times 100%, where n is the number of people you've polled. So you know, you watch those politicians, they're running for office, and it's like, so-and-so has a 47% approval rating, plus or minus 2.5%. Well, how do you get that 2.5%? Well, if you know the number of people that got polled, 2,372, you can take that and divide 1 by the square root of that and multiply by 100%, and whatever's left will be your percent, and that's your margin of error. That tells you how far on either side. So 47% approval rating plus or minus 2% gives you either 49 or 45 as your actual range of somewhere in there is the true approval rating, but we only sampled a few people, and so we're not exactly sure. So I think now you're ready for 12.1 through 12.4, and then after you've worked through that, we can talk about regression lines in 12.6.